The next big main system is going to be drivetrain. Now, I did say that the term powertrain meant engine, right? So kind of everything we just talked about fell under powertrain. Drivetrain is something different. It's something that is pretty much starting right after the engine is ending, right? So we got our engine. After the engine, where does all of that power go? That power goes to our transmission, differential, and drive axles down to our tires, and then we go. So our drivetrain is pretty much going to be all those components in between. So it's going to consist of the clutch, if it has one, a transmission, a drive shaft, a differential, a transfer case, if that has one. The transfer case is really only going to be for four-wheel drive vehicles. But that's what this whole big system is going to consist of. So the clutch is designed to either engage our drivetrain or disengage our drivetrain. So our engine never stops running. When you're at idle, sitting at a red light, your engine doesn't just stop. Well, sometimes it does. I know that there's an idle stop function. But if you're in an old school vehicle, your engine doesn't just stop. It stays running, but the car stops. So here's what happens. Your clutch is separating your drivetrain from the engine. So the engine can continue running. So here's the deal. Your engine is running. Your transmission, we'll talk about that in a moment, is running. That's going to send power out to our axles, which is going to spin our wheels. Well, here's the deal. If I stop my wheels, I stop my axles, I stop my transmission, well, doesn't that stop the engine? It does. And so if you have a manual transmission vehicle, you'll notice that if you're not smooth enough with the clutch, it will stall. And if you've heard of an engine stalling, then you know that it's a little bit embarrassing, right? You're at a red light and you didn't let off on the clutch quite smooth enough and the engine just stopped. That's because you used the vehicle's drivetrain from the drive axles to the transmission to actually stop the engine. The engine didn't have enough power to overpower that. What we want is a smooth transition to connect them so it can slowly, the engine can slowly start to turn the transmission, to turn the axles, to turn the wheels. And that will allow our vehicle to continue moving forward. If we don't do that smoothly, then we stall. And our clutch is meant as that doorway, essentially. It is either going to connect the transmission and engine together or disconnect the transmission and engine together. So when you press on the clutch pedal, you are disconnecting and allowing the engine to run while the vehicle is stopped. When I let off of my clutch pedal, I am bringing them back together so my engine can now drive the transmission, can now drive the drive axles, can now drive the wheels. And clutches are for manual transmission vehicles. So for a manual transmission vehicle, everything is manual, right? So when you select a gear, 1, 2, 3, 4, 5, you are manually selecting which gear you want. I'm not going to get too into it right now, but the reason why we have to even have a transmission is full of a bunch of gears. Why do we need this? Why do we have to have a middleman? Why can't we just have the engine straight to the axles and the wheels? You would have such a small window of power and speed that you would have such a hard time taking off at red lights, and you would not have a very high top speed because your engine only makes a short window of torque. With gearing, we widen that range. And when I use the term torque, again, I'm using terms that we haven't really quite talked about. So if you're not familiar with the term torque, I'm referring to a turning or twisting force. Your bicycle pedals, when you turn those bicycle pedals, you are creating a turning or twisting force, a torque. So the higher that torque, the stronger that turning or twisting force is. The lower the torque, the less force we have. Well, utilizing certain gear ratios, maybe a small gear driving a large gear or a large gear driving a small gear, we can either multiply torque and reduce speed, or increase speed and reduce torque. Again, a whole nother lecture. But that's what our transmission is doing. In first gear, when you put your vehicle in first gear, we are multiplying torque, but we are reducing speed, which is why your top speed in first gear is like 20 miles an hour redlining, right? Second gear, it gets a little bit better. We are increasing torque, but not quite as much. We are reducing speed, but not quite as much, so we're allowed to go a little bit faster. We then go to around fourth gear, which is around a 1-to-1, meaning no torque multiplication, no speed multiplication. It's just what the engine puts out. And then we get into our overdrives, like fifth and sixth gear, where we have a reduction in torque, which is why you don't take off in fifth or sixth gear, but we do have an increase in wheel speed, which is why you're allowed a much higher top speed in those higher gears. So manual transmissions allow the driver to select torque multiplication or speed multiplication. So that's sort of nice. So with automatic transmissions, we are no longer dealing with a clutch and a clutch pedal, right? You just step on the brake and you stop, and the engine keeps running. So how does that work? If I take one fan over here, if I was to pull over a fan and I had it spinning, I plugged it in, and I had another fan over here, but it wasn't plugged in. Well, this fan is going to blow air into this fan, and it's going to cause this fan to spin, right? That's essentially how your torque converter works. When your engine is spinning, it is spinning one side of the torque converter, but instead of air, it's moving fluid. Automatic transmission fluid. I'm not going to get too into how torque converters work right now, but it is really important that we know that this portion right here, the torque converter, allows the vehicle to be in gear with your transmission, right? In a manual transmission, you'll just stall while the engine is still running. Here's the downfall: because we're using fluid movement to transfer power, we do lose about 10% of power, so we're only transferring about 90% of power. Up till a certain point, there is a clutch that gets engaged, but again, more for a transmission class. But that's how our torque converter works. So instead of a clutch on a manual transmission vehicle, we're using a torque converter on an automatic transmission vehicle. So the automatic transmission itself is a little bit different. We don't use the same type of gears as a manual transmission, but we are still using gear ratios. So first, second, third gear is going to be torque multiplication, right? We can still multiply torque in an automatic transmission. Same with fifth and sixth gear, where we call those an overdrive, where we're multiplying speed and not torque. We can still do this with an automatic transmission. We just do it through something called a planetary gear set. We will get into this when we get into the automatic transmission section in this class, a little bit more in depth. But automatic transmissions in general are a little bit more complicated than a manual transmission vehicle. Now, after that are the driveline and the drive axles. So once we have multiplied torque or multiplied speed, what do we do with all this torque or speed? It gets transferred out to our drive wheels. So some vehicles will use the front wheels for driving, some will use the rear for driving, some will use all four for driving. Regardless, the axles that transmit power from the drive piece to the wheels are called our driveline or drive axles. So on front wheel drive vehicles, we use what we call a CV axle. We'll talk about this later. The best, and you guys have this in your Canvas presentation. On a rear wheel drive vehicle, I have a longitudinally, meaning long ways mounted engine that is mounted from front to back, that is going to have a drive shaft that's going to go to a back differential. We'll talk about differentials later on. And then we're transferring power through drive axles in the rear. On a front wheel drive vehicle, we have the engine that is mounted transversely, meaning from side to side, right to left, right? And on the side, we have what we call a transaxle. I'll talk about that in the next slide. Same thing as a transmission. Then we've got our CV axles that go out to our drive wheels. And in an a four-wheel drive vehicle, we've got the engine, almost like a rear-wheel drive setup where it's got the transmission, a drive axle, and my differential and drive axles. But in the middle, we have something called a transfer case. And we will talk about more of this when we get into the transmission sections of this class. But it's going to have a whole nother axle that transfers power to the front wheels as well. So I've got power from the engine transferred to the rear wheels as well as the front wheels. Now a differential, we are going to spend almost an entire class session on because there's so much to this. But in a nutshell, if you are running down a track, take your high school days, go back, time travel back to your high school days, you're running on the track, and the coach tells you to run a mile, or your PE coach tells you to run a mile. Am I running a mile on the inside of the track, or am I running on the outside of the track? My lazy butt's going to be running on the inside of the track because it's the shorter distance and I'm lazy. Well, think about when your wheels turn around a corner. The whole car is going to turn around that corner. Well, your inside wheels, you can think of the inside of the track, while your outside wheels are running on the outside of the track. So your outside wheels, in order to travel that same sort of distance from point A to point B, they're actually traveling a further distance, which means they need to spin at a higher speed. Again, I'm oversimplifying this because this is just systems and we're going to get into this in an entire lecture, and I have some really cool videos for you guys. But in a nutshell, your differential allows your right wheels to turn at a different speed than your left wheels, because when I go around a turn, they do have to travel different distances from point A to point B at the same time, so they are going to have to travel at different speeds, and that's what your differentials do. So underneath the vehicle on a live axle, this is a solid rear axle with a differential, solid rear live axle. In a front wheel drive vehicle, this is included inside the transaxle. So a transaxle is the same as a transmission. It does the same thing. It has a bunch of gears inside of it to either multiply torque or multiply speed. The difference with a transmission versus a transaxle is the transaxle actually has the differential inside of it. A lot of vehicle manufacturers may call this sort of a final drive, but it's doing the same thing. It's allowing your right wheels to turn at a different speed than your left wheels. We'll talk about limited slip differentials and all that fun stuff at a later time. But if you have any questions at all, please make sure that you're writing them down so we can talk about them in our Zoom session. Transfer cases, I did already previously mention, are for four-wheel drive vehicles. I sort of already showed you guys a picture of that. If you haven't already looked at the presentation, the picture I feel like explains it a lot better than I can in words. But it's taking power and it's diverting some of that power to the front wheels as well as the rear wheels. Here's the big difference between all-wheel drive and front-wheel drive, in case you guys were wondering. All-wheel drive vehicles are all-wheel drive all the time. Four-wheel drive vehicles are four-wheel drive when you want them to be, and two-wheel drive when you want them to be. So just so you know, four-wheel drive means you can select two or four-wheel drive. All-wheel drive means it's all the time. Suspension is going to be your springs, your shocks, your control arms, everything that makes the vehicle ride nice and smooth. Dampen road imperfections, allow you to take turns at a good speed and still maintain control of the vehicle. We actually have a couple presentations on suspension. I'm going to talk to you guys about alignment, camber, caster, toe, how to properly lower your vehicle, all that fun stuff. But that's suspension, and that's really the main job, which is actually a really basic job. Give you a comfortable ride and help you maintain control of your vehicle. Steering is exactly what you would think it is, to help you maintain directional control of the vehicle. I'm not going to get into a bunch of different steering types, but when you turn your steering wheel, there's a bunch of components that move that are going to steer your front wheels either to the left or to the right, and sometimes your rear wheels. Your braking system, again, does exactly what you know it to. It's going to slow or stop your vehicle. It may be disc or drum in design. When we get into brakes, I'm going to talk all about that. And it may, when I say may, it will. All newer vehicles will be equipped with ABS. ABS is anti-lock braking system, not anti-braking system. And it's exactly just that. It's to keep you from locking up your brakes when you stop the vehicle, because when I lock up my wheels, I have no directional control, and I'm just going to keep driving right into whatever direction I'm going, and that's a problem. So your braking system is to help slow the vehicle, help stop the vehicle while maintaining control, and that's what ABS does for you. But again, a whole nother lecture. Last but not least, let's talk a little bit about the body and frame of your vehicle. So there's actually a bunch of different types of frames and styles of frames, but I'm really only going to talk about two because there's really only two that you guys are going to see out in the field besides something like Lamborghini. The first one is what we call body over frame, meaning that your body, the body of the vehicle, is actually separate from what we call the chassis of the vehicle. The chassis of the vehicle is going to be your frame, your suspension, your brakes, all that good stuff, and your body simply sits on top of that and bolts down onto it. What is cool about body over frame is it's rigid. I've got another picture here. Here's a type of ladder frame. This is a solid sort of ladder frame design. We've got these cross pieces here are what we call cross members. This actually looks sort of like a solid axle back here, but these cross pieces are cross members, and this is all to keep the frame nice and rigid. Body over frame is a very heavy duty, strong design. Here's the problem. It is heavy. So you'll notice the vehicles with this design are going to be your trucks and SUVs. But any other vehicle, they don't use this design because it is heavy. And anything that's heavy gets worse gas mileage. Here's another picture of a truck design. So the body is sort of translucent so you can see the frame inside. But newer economical vehicles, and when I say newer, I'm really talking about like 80s, 90s and up. We went to a unibody design or unibody construction, meaning that the whole body of the vehicle is essentially your frame. Notice we're missing the roof and the doors and the hood and stuff like that. Those are pieces that will bolt onto the vehicle. They're not part of the frame, but besides that, the whole vehicle is the frame. Here are the pros. So we have a lighter design. That big, heavy frame is no longer part of it. So that is lighter, better fuel economy, better emissions, right? Also, when you get into a car accident, you do have these sort of crumple zones that allow the driver to, and the people inside the vehicle to be safe. So lots of people are like, man, they just don't make cars like they used to. You know, you could get into a car accident, nothing would happen to your car. Here's the deal. There's a reason why we don't make cars like that anymore. Because actually, I believe James Dean was a pretty good example of this. When you used to hit things with cars back in the day, since there wasn't a crumple zone, the car wouldn't damage. Here's the problem. You would, because your body is not meant to go from a high speed to a stop really quickly. Your internal organs do not like it. And so for that reason, we need to slow that process down. So if I'm driving my vehicle, and let's say here's a wall, and I'm driving my vehicle, if I hit this vehicle and I just stop, my body stops. And my heart stops, my lungs stop. They're not ready for that. I die. If I slow that process by creating a crumple zone that will crumple as I hit the wall, I'm able, instead of going to 50 miles an hour to 0 in no time flat, I'm able to go from 50 to 30 to 20, and it might be in a very short time, but I'm still able to slow that process down, which is safer for me, the driver, and any passenger that's in my vehicle. So and if I'm to hit somebody, it's actually safer for them as well. So the vehicle suffers while the people don't. And that's the reason why our cars crash like that. But that's one of the pros of our unibody construction. But the full frame design does have some of those crumple zones on the body, but the frame is really rigid, and so we don't have that as much. Here's another underbody picture of this design. We do have our pinch rails, which are really strong, our subframes, which are really strong, and we'll talk about how to lift a vehicle later on in the semester. And that's all of our systems in a nutshell. That's what our semester is going to look like in a nutshell. Each one of those subsystems, we have a whole lecture talking about just that. So, I'm really excited, and I'm looking forward to the semester, and I'm looking forward to interacting with you guys. So please, 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 if you had any questions at all, please write them down. I would love to address them in the upcoming Zoom session this Thursday. If you're like, whoa, that was way too much information, too fast, go back and rewind that and pause it, write stuff down. Again, I can't help you guys with stuff that you don't let me know that you're having problems with. So if that was super easy, please stop by in the Zoom session just to let me know what your experience is. This first Zoom session this Thursday, I'm really looking forward to seeing what you guys have as far as your history goes, as far as your experience goes, and all that good stuff. I do promise that our lectures in the future are going to be a lot more specific, and I'm not just going to blow right through stuff. So just keep that in mind. Bear with me, and I will see you guys in the Zoom session this Thursday.